March 1944. Cold rain across England. Major Douglas Whitfield stands in a depot workshop near Southampton, staring at a disassembled tank gun recoil cylinder. He is an ordnance officer in the United States Army. The cylinder walls show deep scoring marks. Metal particles glitter in the drained hydraulic fluid. This is the fifth failure this week. Allied armored divisions are preparing for the largest amphibious invasion in history. Their tanks depend on hydraulic recoil systems to absorb the shock when main guns fire. Without functioning recoil mechanisms, a tank's gun becomes unusable after a single shot. The barrel jumps violently backward, damaging mountings and injuring crews. Whitfield has identified the cause. Microscopic metal particles from accelerated wartime manufacturing are contaminating the hydraulic fluid. These particles act like sandpaper inside the cylinders, abrading the precision machine surfaces. Tanks are arriving from American factories with contaminated fluid already in their systems. The scale of the problem is enormous. Hundreds of tanks are experiencing recoil failures within days of deployment. Some guns fail during training exercises. Others break down during transport to staging areas. Whitfield calculates that if this continues, a significant portion of Allied armor will be combat ineffective before the invasion begins. He requests Swedish precision filters, which can remove particles down to 5 microns. The answer comes back within a week. Sweden is neutral. Their filter technology is unavailable. Trade restrictions prevent export of strategic materials. Whitfield turns to American manufacturers. He contacts filtration companies in Detroit, Cleveland, and Pittsburgh. None have experience with the precision required. Industrial filters are designed for larger particles in mining equipment or factory machinery. The tolerances needed for tank hydraulic systems are an order of magnitude finer. One engineer tells him it would take 6 months to develop appropriate equipment. Whitfield does not have 6 months. He has perhaps 8 weeks before the invasion. He begins designing his own solution. The concept uses multiple stages, each removing progressively smaller particles. The first stage employs magnetic separation. Whitfield orders powerful electromagnets installed in fluid reservoirs. As contaminated fluid circulates, ferrous metal particles are pulled to the magnet surfaces. This removes the largest contaminants, but many particles are non-ferrous. Aluminum, brass, and bronze fragments pass through unchanged. For these, Whitfield develops centrifugal purification chambers. The design is adapted from dairy cream separators. Contaminated fluid enters a rapidly spinning chamber. Centrifugal force drives heavier particles outward to the chamber walls, where they collect in a sediment trap. Cleaner fluid exits from the center. The chambers spin at 3,000 revolutions per minute. Whitfield tests prototypes in the Southampton workshop, measuring particle counts before and after treatment. The combination of magnetic separation and centrifugal purification removes 92% of contaminants. But removal is not enough. Whitfield needs a way to verify fluid cleanliness in the field. He cannot rely on laboratory analysis at every depot. He develops a simple testing protocol using white filter papers and measured fluid samples. Maintenance crews pour a standard volume of hydraulic fluid through the paper under controlled pressure. The staining pattern and particle visibility indicate contamination levels. Whitfield creates a reference chart with photographs showing acceptable versus unacceptable results. Any crew member can perform the test in 5 minutes. The equipment exists. The testing method works. Now Whitfield faces a different challenge. He must train hundreds of maintenance crews across dozens of depots in England and Scotland. These men are skilled mechanics, but they have no background in fluid dynamics or contamination control. Many have never considered that invisible particles could destroy a gun system. Whitfield writes a training manual. He keeps the language direct and practical. The manual explains what contamination does, why it matters, and exactly how to prevent it. Each procedure includes photographs and step-by-step instructions. He begins traveling to depots. At each location, Whitfield conducts intensive 8-hour training sessions. He demonstrates the magnetic separators and centrifugal chambers. He shows mechanics how to perform the filter paper test. He brings damaged cylinders and lets them feel the abraded surfaces. The physical evidence is convincing. Mechanics understand immediately that contaminated fluid will destroy their tanks. Whitfield emphasizes one principle above all others. Never assume fluid is clean. Always test. Always filter. The assumption of cleanliness has already disabled dozens of tanks. Whitfield establishes a priority system. Tanks designated for the first invasion waves receive immediate attention. Their hydraulic systems are drained completely. The fluid passes through magnetic separation, then centrifugal purification, then a final polish filter. Crews test the fluid 3 times during the process. Only when all 3 tests show clean results do they refill the recoil systems. The process takes 6 hours per tank. Whitfield has mechanics working in shifts around the clock. He identifies a second problem. Even with clean fluid at the depot, contamination can occur during transport to forward positions. Rough roads shake particles loose from reservoir walls. Vibration dislodges sediment from corners and fittings. Tanks arrive at staging areas with fluid that has degraded in transit. Whitfield needs filtration capability near the front lines, not just at rear depots. He designs mobile filtration units. Each unit consists of a magnetic separator, centrifugal chamber, and testing kit mounted on a wheeled cart. A small gasoline engine powers the centrifuge. The entire assembly weighs 200 pounds and can be towed by a jeep. Whitfield orders 50 mobile units built by a machine shop in Birmingham. The shop works from his hand-drawn plans, fabricating components from available materials. Steel drums become fluid reservoirs. Electric motor housings are adapted for the centrifuges. Within 3 weeks, the first units are ready. Whitfield assigns them to forward maintenance companies, the units that will follow armored divisions across France. He trains their crews personally, emphasizing that these mobile units are the last line of defense against contamination. By late April, the system is operational across the entire Allied armored force in England. Every depot has magnetic separators and centrifugal purification chambers. Every maintenance company has trained crews who understand contamination control. Mobile filtration units are positioned with forward elements. Whitfield establishes a reporting system. Each depot sends weekly summaries of recoil system failures. The numbers begin to change. In the first week of March, before Whitfield's program began, 47 tanks experienced recoil failures. By the last week of April, that number has dropped to 10. Whitfield analyzes the data carefully. The 79% reduction in failures exceeds his projections. More importantly, the remaining failures show a different pattern. They result from mechanical wear or manufacturing defects, not contamination. The hydraulic fluid in these systems tests clean. The problem Whitfield was assigned to solve has been effectively eliminated, but he does not stop. He continues visiting depots, observing procedures, and refining techniques. He knows that vigilance must continue through the invasion and beyond. In early May, Whitfield receives new orders. He is to accompany the invasion force as a technical advisor on armored maintenance. His mobile filtration units will go ashore in the second wave, immediately behind the combat tanks. Whitfield prepares detailed instructions for the maintenance crews who will operate these units under fire. The procedures must be simple enough to execute in field conditions, with limited light and under time pressure. He reduces the process to its essential steps and creates laminated instruction cards that crews can carry in their pockets. On the 6th of June, Allied forces land in Normandy. Whitfield goes ashore on the 8th of June. His mobile filtration units arrive on the 9th of June. Within a week, they are operating just behind the front lines. Tanks rotate back from combat positions for rapid maintenance. Crews check fluid contamination, filter when necessary, and return the tanks to action. The entire process takes less than 2 hours. Whitfield moves between units, troubleshooting problems and ensuring procedures are followed correctly. The spring offensives break German defensive lines. Allied armor pushes inland, engaging in sustained combat operations that would have been impossible with unreliable gun systems. Whitfield's contamination control program has ensured that tank main guns remain operational. The firepower advantage that Allied commanders depend on is maintained. Tanks that would have been disabled by recoil failures continue fighting. The cumulative effect across hundreds of vehicles is substantial. Armored divisions maintain their combat strength through weeks of continuous operations. Whitfield remains in France through the summer, adapting his procedures to field conditions. Dust becomes a new contamination source. He develops pre-filters for air intakes on the mobile units. Maintenance crews learn to position equipment to minimize dust exposure. The testing protocols prove their value repeatedly. Crews catch contamination before it causes damage. The filter paper tests become routine, performed as automatically as checking oil levels. By August, Whitfield's system has been adopted as standard procedure across all Allied armored forces in Europe. Training manuals are distributed to units in Italy and to forces preparing for operations in the Pacific. The principles of contamination control that Whitfield established become foundational to armored maintenance doctrine. His magnetic separators and centrifugal chambers are refined and improved, but the basic design remains unchanged. Whitfield returns to England in September 1944. He is promoted to lieutenant colonel and assigned to write the official technical manual on hydraulic system maintenance for armored vehicles. The manual incorporates everything he learned during the crisis months of early 1944. It emphasizes testing, filtration, and the assumption that contamination is always present until proven otherwise. The manual remains in use for decades after the war. The recoil system crisis that threatened Allied armored operations in March 1944 is largely forgotten. It does not appear in histories of the invasion or accounts of armored warfare. Yet its resolution was critical to Allied success. Whitfield identified a silent killer that was disabling tanks faster than combat could. He engineered a practical solution using available materials and limited time. He trained hundreds of crews to implement that solution under field conditions. The result was a 79% reduction in gun system failures during the most critical period of the war in Europe. Whitfield's innovation was not in developing new technology. The principles of magnetic separation and centrifugal purification were well established. His achievement was recognizing how to apply these principles to an urgent military problem, then creating a system that could be implemented rapidly across a massive organization. He understood that the solution had to be simple enough for mechanics to execute in depots and battlefields, reliable enough to work under adverse conditions, and fast enough to process hundreds of tanks in weeks. After the war, Whitfield returns to civilian life. He works as a consulting engineer for hydraulic systems manufacturers. His wartime experience with contamination control influences the design of industrial hydraulic equipment for decades. He dies in 1972 at the age of 63. His obituary mentions his military service, but does not detail his work on tank recoil systems. The mobile filtration units he designed are eventually replaced by more sophisticated equipment, but the fundamental approach he established remains. Modern military hydraulic systems still use multi-stage filtration. Maintenance crews still perform regular contamination testing. The assumption that fluid must be proven clean, not assumed clean, is now standard practice. These principles trace directly to the emergency program Whitfield created in the spring of 1944. What remains is a lesson in practical problem-solving under extreme pressure. Whitfield faced a crisis that threatened to cripple Allied armor before the invasion. He had no access to ideal solutions or unlimited resources. He worked with available materials, existing manufacturing capacity, and the skills of ordinary maintenance crews. He created a system that was good enough, fast enough, and simple enough to solve the immediate problem. That system saved hundreds of tanks and maintained Allied firepower during the operations that decided the war in Europe. The contamination that would have silenced Allied guns was filtered away by magnetic separators, centrifugal chambers, and the trained hands of mechanics who learned to test every sample and trust no assumption.